Hi everyone, and welcome back to our new Breakpoint series. My name is Michelle Sandford and I'm the Developer Engagement Lead at Microsoft, and I am super excited to host Season 4. For those tuning in for the first time, New Breakpoint is a show for developers by developers, and we'll discuss a range of topics with an incredible lineup of guests. This show will be broadcast on the second Thursday of each month, with a short break in December and January. Each hour-long episode will include Q&A, and the guest and I will both be online and answering questions throughout the episode. So if you miss the broadcast, do not worry. As long as you register, you can watch the show on demand afterwards, and you won't miss anything at all apart from the Q&A. Why tune in, you ask? Not only will we deep dive into the latest developer technology, industry updates, and help you upskill yourself personally and professionally, but we want you to be part of our developer community and to stay in the know of what is new and interesting to us. Today I have with me Scott Hunter. Scott works on the Azure Developer Experience Team at Microsoft. His team builds all of the tools for Azure, Command Line, VS Code, Visual Studio, the Azure SDKs, and many developer services including App Service, Azure Functions, Azure Container Apps, and many more. Before the Azure Developer Team, Scott led the ASP.NET and .NET teams, rebooting .NET with .NET Core and ASP.NET Core. He's also a hiker and a Formula One fan. Please join me in welcoming Scott Hunter, who is the VP of what?
I work in the Azure Developer Experience Team. It's a weird term, but the team that I work on, we build all of the Visual Studio Code, and command line tools for Azure. We build all the SDKs across all the languages for accessing Azure, and we build a bunch of the PaaS services, things like App Service, Container Apps, Functions, but we also build API management, logic apps, a wide variety of services that we think developers would want to use, and we think our magic DNA is because we build the tools, the SDKs, and the services, we try to make those a really great developer experience.
Certainly sounds like it. And how long have you been leading that team?
About 2.5 to 3 years, I would say. So Microsoft is a weird company. I joined Microsoft back in 2007, and I was part of the ASP.NET team. And then in 2011, when Scott Guthrie left DevDiv, Developer Division, and moved to Azure, he took anything that was web related with him. So we came to Azure with ASP.NET and the web tools for Visual Studio, and we actually worked on all those same services. And then a bunch of us, David Fowler, Damian Edwards, Scott Hanselman, and myself, and many, many others, we started looking at the .NET technology back then, which was Windows only. And we realized for the cloud to work for .NET, we had to be cross-platform and open source. And so we started this journey of we called it ASP.NET 5, then it was ASP.NET vNext, which became ASP.NET Core. We started that over in the Azure team, and then Julia Lucen over in DevDiv was like, Scott, you have to come to my team, because we're the team that owns all of .NET. Come to my team and complete this .NET Core journey. And so I moved back to DevDiv in 2016 to work on the .NET Core bits. And then oddly enough, about 2.5 years ago, all those services we worked on under Scott Guthrie moved to DevDiv. And I say it's a weird world because we all worked on those things before we left, and all that tech came back. It feels like you can't get away from anything in Microsoft. It always comes back around and finds you again.
So it follows you.
It follows you somehow.
But is it the stuff that you love follows you, or is it that you find yourself gravitating back to the stuff that you love?
At my heart, I'm a web developer. And so, those services are very interesting to me because as a web developer, I want to be able to build the best cloud services for a web developer. And so I feel like I'm privileged to be able to work on the web tools in Visual Studio and VS Code, to have worked on ASP.NET Core, and now to work on the services that you would host your web applications on. So it feels like it's the whole continuum lives in DevDiv, and we can make it all better. And I think we're going to talk about Aspire today, and Aspire is kind of like the culmination of all the best things to make a great web application that runs in the cloud.
It does sound like it is the answer to everything that the world has been waiting for.
That's too far.
Well, I was looking at it and I'm just like, there's all these big enterprise companies that we have out there, and they have built themselves over these years on these massive applications. And a lot of them found themselves very stuck in a world where it's difficult to move forward when you are built on this massive application. But Aspire is going to help them with that, right?
I think it will. Aspire, interestingly enough, when I was in .NET, one of the things that we talked about was if you're in the Java world and you want to build a cloud native application, likely you're going to use Spring. So Java has this framework that is known as their cloud native framework. And we had customers that would tell us, we moved from .NET to Java because there's a framework for building these cloud native applications. And here's a funny story. Most of the things that make Aspire interesting are things we shipped a long time ago. So I guess I should start and say, what is Aspire? Aspire is meant to be a cloud native framework for .NET. But we don't want to have you rewrite your application either. It's like, as I said, we built things like resiliency. And what resiliency is when you're in the cloud, if you make a call to a database or a call to an endpoint, maybe it takes too long sometimes just because of network latency or something like that. And so we call this resiliency, where when that happens, we want the framework to go, don't just crash, maybe try again. And so we actually built that feature into ASP.NET Core 3.0 many, many years ago, but it was not on by default. Then around the same time, if you're in the cloud, so we talked about resiliency. Another thing that's important in the cloud is you want the cloud to know if the application's healthy. And so we built a feature in ASP.NET Core 3 as well called health checks. And health checks is literally some URLs that the cloud can call to ask the app, is the app okay? And things like Kubernetes will actually call those health checks, and if they fail, it'll restart the entire process. And so, once again, built in ASP.NET Core 3, nobody knows that it's there. And then a couple of versions ago, we added OpenTelemetry support to ASP.NET as well. And OpenTelemetry is a way of taking your diagnostic data and publishing it in a open source common format that a variety of listeners can listen to and display however they want. Once again, not on by default. The idea behind Aspire is to give people great defaults, is what I would say. Here's all the things that should be turned on. It took us a long time to ship Aspire because we were also afraid we would get the defaults wrong. But we solved that in Aspire because one of the projects in your Aspire app is the default project, which contains all the defaults. So you can actually open that project up, jump into the files, and change the defaults if you don't like the defaults. So if you don't want to use OpenTelemetry, then go turn it off and pop in whatever telemetry you want. But the idea behind Aspire is to give you a great path forward where we've chosen all the right defaults for you. Another thing .NET's not been great at, not just .NET, Node, Java, Python, we all have the same problem. If you're building a cloud native app, you're probably either going to use VS Code, and you might have one version of VS Code with your front end, one with your back end, and you run them both. If you're in Visual Studio, maybe you right click and you say startup projects, and you select multiple projects. That's a kludgy solution as well. And so we've never had great support for running multiple applications in our tools as a developer. So it's like, let's do resiliency, let's do logging, let's have great defaults, and let's support projects that are apps that have more than one projects in our tools. And those are some of the core key things that Aspire tries to solve.
As I'm listening to all of those, I'm thinking there's probably like a couple of other things that everyone's talking about at the moment, and I wonder what Aspire does around those things. So AI and security. If
you want to delve in those areas, that's another component of Aspire. And to talk about AI or security, first we have to talk about how you publish an app. So something else. If you've been using ASP.NET for a long time, you have right-click publish, which, there's, my friend Christy has always likes to say, tell friends not to do that.
Damian Brady has a sticker for that.
But the joke is, as a developer, those publishes are meant for developers. They're not meant for production applications. But once again, just as I said, we've never had a great solution for running multiple projects. We don't have a solution in our tools for publishing multiple projects either. And so, as we looked at doing publish support for Aspire, my team, the Azure Developer Experience Team, we have a tool called AZD, and that's aka.ms/AZD if you want to find that. And that's a tool we wrote about 2 years ago, and the idea was, hey, we've got these complex Azure samples, and they're hard for our customers to try, because you would go to GitHub, you would pull the code to your machine, and then you would look at the README and you'd say, oh, I have to run like 15 command line tools to make the application work. And if you mess any of that up, you have to delete the whole thing and try again. And so AZD was meant to solve that. But as Aspire started happening, we said, hey, let's make AZD the tool to publish an Aspire application. If you're doing Azure Publish. There's actual other tools that exist for publishing an Aspire app to like AWS or GCP. So Aspire, what actually behind the scenes it does is there's a manifest created when you compile an Aspire project. Then our AZD tool can look at that manifest, and from that manifest we can say, oh, wait, see, there's multiple projects here. Let's go and publish those. And what we actually technically do is we write the bicep files for you. They're hidden by default, but you can run an AZD command that will actually publish those if you want to hand edit those things. This is important because that's how we publish an Aspire application. If you take a default Aspire application and just publish it, it'll put it in Azure, in an Azure Container App, and you won't be able to hit it because it's not available on the public internet. Mm-hmm. You have to go into your actual host project in Aspire and put a line of code in there saying that you want it to be externally available. And that's the beginning of security. Mm-hmm. So each Aspire project has to decide, if I have a front end and a back end, I might want to make the front end available to the internet. I don't want to have the back end be available to the internet. Mm-hmm. One of the other cool parts of Aspire is it's got a notion of what we call components, and some of those components are Azure resources. So there'll be a NuGet package for an Azure Redis cache. There'll be a NuGet package for a SQL server. There'll be a NuGet package for a Postgres database. And what's cool about this is, so your Aspire project, you define what resources you need. And the resources could be you define, I want a front end, I have a back end, I have a cache, and I have a database. Now what happens is when we publish that to Azure, we are going to publish that using the best security methods that are available. Our preferred way of doing security in Azure is a technique called managed identity. And the idea here is, the scariest thing you read about all the time, people that have uploaded their apps into like GitHub with credentials, in the source code.
That's an old problem, though, isn't it?
It's an old problem.
Protecting against that now.
It's an old problem. It still happens today. I mean, we have things like GitHub Advanced Security, whose job is to go look at your code and tell you that you have this problem. We get alerts as people inside of Microsoft all the time. Typically, we come to a conference, we have a sample, we might not use the best security things in our sample, and the tools will actually scan and tell us, you have to take this thing out of GitHub right away because we found these things. But the cool thing about the Aspire Publish Tech is we will, by default, try to use managed identity if the services that you're using support managed identity. If they don't, Aspire will automatically create a Azure Key Vault and put the credentials in the Azure Key Vault. And so by default, the idea is any application that you publish, any Aspire app that you publish to Azure is going to have the best security principles in by default, which is either credentials in a Key Vault or use managed identity if available. And so that means as a developer, your app in Azure is going to have no secrets that are available to the public. There'll be no secrets in source code. So you're going to have the best security as part of that. Now you asked about AI. There's also an Azure OpenAI component. because that's an Azure service that you can actually add to your Aspire application. And once again, we do all that work for you. So we'll do all the credential stuff for you. This is a key component of Aspire. When I've got a web front end and it's going to call, so let's say Azure OpenAI, I don't even have to think about a connection string in Aspire. So what I'll do is when in my host project, that's the orchestration project for an Aspire application, I'll say I want an OpenAI instance, and I'll give it a name, AI. And then in my front end, when I use the Azure OpenAI SDK for .NET, I just have to tell it to use AI as the connection string. And what technically happens behind the scenes is Aspire does all the magic to go figure out did it store those credentials in a key vault? Is it using managed identity? And it just converts the AI into the right thing for you. So it's using dependency injection to convert that name into what it really has to be. And so your application, I never actually have a SQL connection string. I never have a Postgres connection string. I just say SQL or Postgres, whatever name I give that stuff. And then the Aspire host and orchestrator does all the magic to go figure out where those strings are and if you even need a connection string for that. So we try to hide all the credentials away. So it's really cool. If you build a front-end app and a back-end app, this is, once again, a typical problem. It's like on your local machine, you go to launch settings.json, that contains the port and IP address of the app. With Aspire, you never think that. You just give each app a name, and you reference the name in the URL. So if I want to call the backend, if in my host project, if I say my web API backend, I give it a name backend. In my Blazor application, all I do is reference http://backend, and we do that name translation for you behind the scenes, which means you don't have to worry about being on localhost when you're local and whatever endpoint you're going to be when you get to Azure. And so what Aspire does for an AI developer or a security developer is we do all the right security things for you, and we make it very easy to use the OpenAI SDK just by referencing it.
So the whole goal of Aspire is to make things really simple and easier for developers to just do their code, do the stuff that they need to do without having to worry about all the other things that have been making their worlds much more complex in recent years.
Exactly. You don't have to worry about resiliency. You don't have to worry about logging because we're going to turn it on by default. You don't have to worry about how do you do, as I said before, where do you put your IP addresses, your connection strings? We do all that stuff for you. It's super cool. So let's think about this. Let's say you're an existing ASP.NET Core developer. Oh, it's going to be a lot of work to turn Aspire on for my project. We made that very easy as well. You literally open your ASP.NET Core project, you right-click, they'll be in the right-click menu, it'll say add Aspire orchestration. When you click that, what we're going to do is we're going to go create this orchestrator project. That's going to be your host project. We'll put a host project in your solution. We're going to create a service defaults project in your solution. That's the one that has all these defaults that turns on the logging, the resiliency, all those types of things, the health checks. And we'll add a line of code in your current ASP.NET Core project that calls that default project. Which means when your ASP.NET Core project starts up, it's going to go call that and turn all those things on by default. But there's also that host project I mentioned, and inside that host project, there'll be a reference to your front-end application, your ASP.NET Core application. And then if you F5 it, so at this point you've really done nothing. You've changed none of your code. You'll F5 the application, and when it starts, it's going to start up and bring you a dashboard. In that dashboard, you're going to see the logs of the application. You can go look at all the telemetry that's running for the Kestrel web server. There'll be structured logging as well. So, as requests come in, you can go look and see the requests coming into the application and how long they took. You can drill into those and get more details. So you get that dashboard by default. And so it literally is one right click and your project is now an Aspire project. If you have two projects in your solution, a front end and a back end, you right click on both of them and add the Aspire orchestration to each of them, then your host project is going to have a reference to each of those projects. and you can reorder that and change the order. That you want the order to be what project depends on the other project. So what you'll do is I have a backend project and a front end project. I will give the backend project a name, var backend equals the project, and on my front end, I will say it has a dependency on the backend. That tells the orchestrator, start the backend first, make sure it's running, and then start the front end. But that orchestrator project, because it's the only project we really run, that's the one that tells us the smarts of when you boot up, don't just boot up this project, boot up the front end, the back end. That starts this multi-run thing where we actually run all the projects for you. I don't know. There's so much cool stuff. I could talk for hours and hours and hours. But the cool thing is, you don't have to rewrite your application. This is literally, if you're already in ASP.NET Core, right-click, and you've got Aspire running in literally seconds.
So they don't need to download something else or access some other portal. Like how is it there magically?
So if you're using the newer versions of Visual Studio, Visual Studio will install Aspire for you. Mm-hmm. If you're on a Mac or Linux or Windows command line and you're not using Visual Studio, so you're a Visual Studio code developer, you'll have to install Aspire. We built a feature in .NET that was built for building the mobile projects, the Maui projects, called workloads. And we did this because when we were doing Maui, we didn't want to make .NET turn into this huge hulking, framework. We did that before with .NET Framework, where year after year we just shoveled more stuff into it, and it got bigger and bigger and bigger. As we built .NET Core, which is now just .NET, we wanted to make sure that we never got to that state again. And so we have a notion what we call workloads. And so Aspire is just a workload. And so it's an optional install. .NET workload install Aspire will actually install the Aspire workload on your device. So on a Mac, if I have .NET 8 on the machine, I would then just go to the command line and say .NET workload install Aspire. That'll put the Aspire bits on my machine and the project templates, and then I can do a .NET new Aspire.
If you're in code spaces, could you?
Yeah, this works in code spaces, works anywhere. So, and for folks, a lot of folks don't know what code spaces is. I think it's a hidden gem that people don't really know. Well, there's two ways I think about this. There's the ability to, in VS Code, you can have, there's one of the container extensions for VS Code where all your dependencies run as containers. You can use that. Codespaces is technically that, just running in the cloud. But Codespaces is a great way to use this tech and not have anything on your box, which I'm a big fan of as well. That's also another aspect of Aspire that's really cool as well. So we mentioned before using Postgres or Redis or SQL Server. Historically, as a developer, what you would do is you would go install Postgres on your developer machine or SQL on your developer machine or Redis. I don't want to do that. So when I reference any of those components in Aspire, Aspire knows it knows what .NET projects are, but it also knows what other things could be. If you decide to add a Redis cache and a Postgres to your Aspire application, what will happen is when you run it the first time, we will require Docker for Desktop to be running on the machine, and we'll use Docker to download the Docker images for Postgres and Redis, and we'll run them as containers. And so, even though your machine is running, your Aspire app's running, and you can actually talk to Postgres and talk to Redis cache, that stuff's done on your machine. And that's a cool aspect as well. It's like when you stop the application, there is no Postgres running, there is no Redis running, and there is no Redis installed on your machine. You can go to Docker for Desktop and delete the container images if you want. That's another aspect of Aspire that's really cool too, is not forcing the developer to install a bunch of stuff on their machine, because I don't like to install. I like my machine to be controlled by me, and I decide exactly what's on the machine. That's a great component of ability of Aspire as well, is to run all these services that you might want to use as local containers. That same technology understands that in some cases, like for Cosmos, we have emulators. For Azure Storage, we have emulators. You can tell Aspire in the host project to use the emulators, and it'll run the emulators as containers as well. So on your local machine, you're using storage or Cosmos in an emulator. when you publish to Azure, it runs as a proper, Cosmos or storage. And we also understand in some cases there might not be an emulator or a local version of something, and so you can also in the host project say, I want to use, in this case you are going to use a connection string, I want to talk to a Redis cache in the cloud for my local development. Somewhere I need to have bullet points to talk about all the things Aspire does, because we're kind of all over the map. There's so much that's there.
I'm afraid it's rather typical of having conversations with me. I am all over the place. My brain does tend to get excited by one particular thing you mention, and then I say, let's go over that. But yeah, I think people will humour us. They can see the excitement.
As I said, this is the culmination of all the .NET Web tech we built in the last 5 or 6 years. I think it pulls all the best parts of it all together, and adds the right components that were missing before. We never had the ability to run an app with MySQL on your local machine super easy. I said you had to install MySQL, you had to do all the connection string magic. In the case of Aspire, what does a MySQL connection string even look like? Mm-hmm. I don't even worry about that. I just say, give it a name and reference the name, and the magic happens.
I've seen a lot of stuff this year where people are talking about cloud native, but I still think a lot of people don't even understand what cloud native is. And there's been a lot of muddying of the waters with, definitions changing, and that lack of clarity, I think, has kind of put a lot of people off moving to something that should be, in fact, a really efficient way to run. Maybe you could shed some light.
I hate the term cloud native, even though I've used it a bunch of times in the conversation today, because these definitions are so broad. What does it actually mean? There's the CNCF, the Cloud Native Foundation. They have a term for this, and the primary things in the term are, I'll use other words I don't like, microservices. Not a big fan of that, but I really think of cloud native being as the app is observable, which means there's a way to see the telemetry from the application. That's where Aspire uses the open telemetry and has its own dashboard. But by the way, you don't have to use the Aspire dashboard. You can use App Insights, which also understands open telemetry. So one of the notions of a cloud native app is it's observable. Another one is it's manageable. In many ways, to me, what we were just talking about, I can actually reference a MySQL, and we will run that in a container on your local machine, and we'll put that in a proper the Azure service when you're in Azure. That's part of the manageability of the tech. Part of cloud native is being resilient, because in the cloud, it's got to be ready for those things to happen. And the fourth component of that is typically scalability. So an app that's resilient, scalable, observable, and manageable is what we'd call a cloud native app. That's what the CNCF definition would say, if you read the fine prints of the blurb of words they use for this. And so that's all that Aspire tries to do is satisfy each of those pillars. The purist in the world would say a cloud native app is an app that was born in the cloud, meaning that you never ran it on local, you always ran it in the cloud. And I think that is more. Most of us, if we build apps today, we probably aren't running them on our own servers in our offices. We're probably running them in the cloud. And so I would say most apps are probably cloud native today, just from those loose definitions. But I hate the term. Yeah, as I said, definitions, microservices, containerized. And that's another cool thing of Aspire too. There's more and more of these is when you publish your Aspire app to the cloud, it runs in containers. But we don't require you to write Docker files. If you want to write a Docker file, you can. But that we imply that for you. We just do all that stuff for you. So we'll generate the Docker file on demand for you for the application. And so to me, it makes the goal of Aspire is to make these types of applications accessible to you. I don't have to worry about, do I need Docker files? Do I need Helm charts? I don't want to think about those things. If you know about them and you understand them, great, put them in your projects. If you don't.
They have the choice, and if they want to understand what's happening there, they can see it, but they don't have to if they don't want to. It'll just be done for them.
It's just done for you. even outside, if I go outside of Aspire, one of the things that my team builds the tools for Azure Container Apps, and same scenario. We don't want you to have to think about that. The VS Code extension for container apps, just pointing to your application, whether it's a Python app, a Java app, a .NET app, a Node app. You don't have to put a Docker file in for that tooling either. We'll actually build a container for you in the cloud and then publish it into the container registry, and your app just runs. And so trying to make all this tech accessible without having you to do all the bits you don't really care about. In most cases, the Docker file, you're not going to change it anyway. It's going to be a default file that you never change. Mm-hmm. So why even have the file?
This is so good, because I think being a developer has gotten at once much, much easier and much, much harder over the last 10 years or so. On the one hand, people get into being developers because they like to code. But as the world has progressed, there's been all of this complexity around all the things they need to spin up before they even start writing a line of code. And that whole expectation that you will shift left as well, that you will do testing, you will do security, you will do all these additional things on top of just the code. As you say, we used to just have all the secrets in the code. Someone else's problem to sort that out.
Scary, but yes.
but yeah, and now there's all of that other stuff. And for me, the biggest frustration is indeed trying to stand up the environments, trying to get things running, which things do you need to download first, which packages are going to conflict with each other, and I would get so frustrated. So I love the idea that this is just going to make things simple for me.
Just imagine all those terms you just used. Imagine it's like, okay, download Docker for desktop, write a Docker file, write a Helm chart, go and write the code to turn telemetry on, go write the code to turn resiliency on, go write the code, to hook all that stuff together. As you said, we went from, when I first started, at Microsoft, it was like file new ASP.NET project, and you're off and running. If you add all that complexity I just described, it's like, okay, create a project and add this and add this and add this and add this and add this. You're right. I think development has gotten more complex the last 5 or 6 years as we've gone through this containerization, the notion of having a Kubernetes potentially running my application. The number of concepts is just like quadrupled or tentupled or whatever the word would be. It's up by 10 times probably. That was what it was. Before it was just file new ASP.NET. Yeah. I never thought about any of these things. Even file new ASP.NET was a little complicated because you had to have your own web server on your machine, IS. But that we made that so simple you didn't think about it. Mm. That's actually always been our goal, all the way back to Steve Sanderson, who is the Blazor architect. He has a great talk. You might have seen it. It's his history of the web. Mm-hmm. And he showed front page and how you built your first page, your website was front page. And he showed Visual Studio.net, and that was how you did ASP.NET projects. Mm-hmm. And all of these things took the complexity out of for the web. The front page, you didn't have to think about the web. You just went and said, I want a corporate website. It built a bunch of pages for you. You went and filled the content in. You're done. Mm. Visual Studio.net back in the day with ASP.NET Web Forms, you drag and drop controls just like you would for a desktop application, and you get a web application. And now Aspire, without having to worry about containers and Docker files and Helm charts and all that stuff, you just say, I want an Aspire application. That's been the gist of all of the tooling and all the frameworks we built at Microsoft, is to take the complex and make it easy.
One of the things you're talking about this week is if you do have a massive application, you want to move it to the cloud. That's been a big problem on a lot of organizations' plates. Is it that easy?
It depends. So we build 2 tools. We have an application code, an Azure application code analysis tool. And what it will do is for a .NET project or a Java project, The tool literally looks at the application and tells you, here's the things you have to change before you put this in the cloud. And so we're building that because I also don't expect, most of our customers probably have 10, 20, 100,000 applications they've built over the last 20 years. They're not going to rewrite them all in modern .NET or modern Java or whatnot. They're going to leave those apps as they are. And so we want to help make it easier for somebody to actually put one of those apps in the cloud. And so we have these tools we built. Right now we have a version for both .NET and for Java. If people ask for it, we would do a Node or Python as well. But we think .NET and Java are the right two because they've been around for over 20 years. And so you're going to have lots of old apps. Node.js was not around 20 years ago, and so likely your Node application is already in the cloud because people started using Node about the same time the cloud was very popular. But these apps, they scan your code, give you a bunch of recommendations on what you need to change. And it's going to be things like, hey, we found a connection string to a local database. Oh, we found your connection string to your local database is using Windows authentication to talk to the database. You need to change these things as you move these apps to the cloud. And so it'll give you a list of things to change. The .NET version is really cool right now. It's got a Copilot button for each issue.
So it'll tell you how to
it'll tell you how to change it as well. And so the session I'm doing, one of the sessions I'm doing this week is literally on showing how we took a 10-year-old MVC application and in 15 minutes we got it ready to go to the cloud. It's not going to be 15 minutes for everybody, but the tools are going to tell you all the things that you're going to have to change. We built these tools because we ourselves, we have we call it a customer success team. And if you call us and say, hey, I need help moving my huge enterprise application to the cloud, this team will do proof of concepts for our customers. And so these cloud tools that we built, they literally are what our own internal teams do when they go and help a customer. So they ended up taking all the lessons they learned as they helped customers move apps to the cloud, they codified them into this tool. And so it's not going to be perfect. It's not going to make all apps go super fast. But there was a customer in Houston, Texas. All of their engineering permits, that was an app they moved from on-premise to the cloud. And they say that tool saved them between 40 to 80 hours of work. And that's the goal, is to make that easier. But it's not going to be perfect, but it will tell you most of the big things to change before you try to run the app in the cloud.
I do think that that's the key for a lot of the improvements that we've been making across our whole stack recently. That none of it is perfect, but that you can work through those problems together. You can ask it, what is the next step? You can ask it, what do you mean by that? You can say, what else do I need to install? You can say, I don't know how to do that. Can you tell me the commands? And whereas previously you would need to go to Google, go to Stack Overflow, and once you come out, that context switching just totally breaks your flow, and it could be hours before you come back to it. So it's not even really the hours you spend working on your thing, it's the hours you don't lose by context switching.
Yes, and trying to go research something you've never heard of before.
And you don't know what to ask next when you're just asking a thing that returns a search, whereas with all of the co-pilots, I really do feel like I have gained a little AI friend that is helping me work through all my thoughts and not mocking me for it.
One of the things that I think people misunderstand with Copilot is, and as I talk to our customers, the first thing customers ask me is, how accurate is the code that it writes? And I hate that question because, as you said, you just described Copilot the best way. It's like, what did you do in the past? In the past, I would use Google or Stack Overflow. I would go find an SDK for what I'm trying to do. And then I would read the docs on the SDK. I would copy and paste some samples of that into my application and run it a few times until I got it to do what I want. Copilot does that without that context switch, as you said. Now I don't have to go to Google or Stack Overflow. I don't have to find the SDK. Is the Copilot's going to recommend perfect? Probably not. But it's the code I found using Google or Stack Overflow was not perfect either. I always started with something I pasted in, and then I tweaked it a little bit to get it exactly what I wanted. And this Copilot does that all inline without having to leave the tool.
And it is actually contextually referencing
Yes.
your code, which Stack Overflow and Google never were.
They don't. You're just pasting stuff in, you're massaging it until you get it into what you want it to be. And so the Copilot thing is super interesting to me,
Yeah, I had exactly the same the other day. I was presenting something for a customer conference, and one of the questions at the end was, what about the hallucinations? We were talking about GitHub Copilot, and I said, what do you mean hallucinations? Because in the context of GitHub Copilot, I wouldn't tend to use that word. And she said, well, when you ask it for the code and the code is wrong. And I was like, oh, because that isn't what I would mean by hallucination, by what we generally mean by hallucinations. The code is wrong. Yes, you shouldn't be expecting Copilot to give you perfect code. You shouldn't expect to be able to have it do your work for you. That's why we call it Copilot. It's meant to be there to be having a discussion with you. It will give you something, you can look at it. If it doesn't work, you can ask about it, you can learn from it, and you can see what else it might suggest in order to improve it or to fix the bugs in that code. But yes, to expect it to just produce the whole thing for you, don't do that. Copilot is not there to replace us.
It wouldn't be called Copilot. You said that perfect. We would call it autopilot.
Yeah.
If it did all the stuff for you.
And we don't want that.
We don't want that. You still have to be a coder. You still have to be able to read the code and see if the code does what you want.
The architecture, the thinking of what our plan is for the application we are building, this is the human ingenuity that we are bringing to it. If you ask Copilot to write the whole thing, it will, but the code is probably going to be a bit bloated because it's trying to incorporate every single thing that it thinks is important, and it doesn't know what your architecture is, what you want it to be.
It might give you code that's not the highest performance code as well. I mean, I guess you could ask Copilot, give me the highest performant way of doing X, Y, and Z.
I do ask it for that.
Do you?
Well, I have a session this week as well where I'm showing people how they can overcome their imposter syndrome using GitHub Copilot, and I ask it, can you make this code more perfect? And then other questions I ask it, can you make it faster? Can you make it cleaner? Can you make it more Pythonic? Can you redo it into an object-oriented style? And just the things that you can learn in those conversations with Copilot, asking it what that means. Well, you don't even have to ask it. When you ask for that refactoring, it will explain to you what it has done and why it's better or why it's not better. And it's interesting because it will use the word better. So you do feel like you're having a conversation with a pair programmer because you are talking in the same language you would normally use. And I love it. I feel I've learned so much more about being a better coder from conversations with Copilot.
Yeah, one of the ones I'm going to show this week as well is we have a feature called code optimizations. This is an Azure feature. Where what we do is we run a profiler on your app in Azure, and you can go look at the profiler, and it'll show you when your app is slow. And once again, it's very Copilot-y. It'll show you that, hey, here's some slow code, and you can ask it to go fix it.
Yeah.
And this goes so far that you can see, oh, this is a slow method in Azure in the portal, and you can ask it, show me how to fix it. It's going to give you a reference. You go to Visual Studio or Visual Studio Code, and you go to the Copilot inside of either of those tools, and you say, here's the thing I got from Azure. And it will literally load the code up in your editor and make the diff and show you the diff, and you can decide if you want to accept the diff. It is super cool. And that literally is, we've been running app service for like 12 years now, 10 years, I think, 10 or 11 years. And so you can assume over time, we've helped lots of customers with performance problems. And so it literally is showing you the the database of that stuff and recommending, hey, we know this will be faster than this. And so I'll share that live actually today.
Well, I will definitely be watching that. Okay, well, I see we have talked for far longer than we should talk. However, I do want to leave them with maybe what would be your call to action for them regarding Aspire.
My biggest call to action for anybody with Aspire is please, install the latest version of Visual Studio. If you're command line, .NET workload, install Aspire, and then go add that Aspire orchestration to one of your projects.
And there's learning paths and everything.
There are. There's just, if you just search for,
we will put them in the resources.
Yeah, there's tons of learning paths and lots of documentation, but really it is as simple as right-clicking, add Aspire orchestration, and run your project. That's it. You don't have to do no more than that. And I think you'll see the first benefits of Aspire right then.
Perfect. Okay, well, Scott and I will hang around for another 15 minutes answering your questions online. So do type those into the chat, and hopefully we will get around to answering those for you. Thanks for joining us, and thank you for joining us.
Thanks for having me.
See you all next time on New Breakpoint.
We hope you enjoyed this digital event. We have specialists on standby to answer your questions for a short while. To ask a question, type it into the chat window now and we'll get to it as quickly as we can. You'll also find a resources widget in the bottom middle of your screen. We've put additional links in there to learn more about what we've covered today. Lastly, tell us how you found this experience through the survey widget. If you're not staying for the Q&A, thank you for attending and we hope to see you again soon.